or negative 1. Today we'll be looking at how to find the zeros of fourth degree equations. That is, suppose you're given an equation of fourth order, fourth degree, an equation of with the power 4. Can we find solutions to this equation? Can we find zeros to this equation? So we'll look at the first, just one example to illustrate this, how to find the zeros or solutions or roots to this kind of equations where we have the highest power being 4. Now, so what I'll do for this kind of equations, what I'll be doing is first of all to find out whether this equation can be reduced, whether we can factorize it. So once we find out whether it can be factorized, then we factorize. And then after factorizing, we solve and find the values of x. So how we factorize this? The first thing I said is find out, can it be factorized? So can we find a solution, one solution? So what I'll be doing is, for me to find out whether this equation can be factorized, the thing I'll be using is that I'll use this constant term here and this leading term here, the one with the highest power of x and the constant one. They'll tell me whether this equation can be factorized, because that is the first thing I need to do. Now, so if this equation can be factorized, then one of its roots should be r over s, where r are factors of the constant term -2, and s are factors of the term 3. So if this equation can be factorized, then one of its roots must be r over s, where r are the factors of the constant term and s are the factors of this term here. So what are the factors of -2? Factors of -2 are positive or -1 and positive or -2. And the factors of, so these are the possible r, or possible r are this, and s, those are the factors of positive 3, which are positive or -1 and positive or -3. So we have our possible r and our possible s. So what are our possible roots? So we want to see if this equation can be factorized, then one of its roots must be the following, one of the following. If r is this and s is positive or -1, then r over s could be positive or -1 and positive or -2. So I've just divided. What about if s is this? If s is positive or -3, then our r over s will be positive or -1/3 and or positive -2 over 3. So what do I mean at this point? What I mean is that if this equation can be factorized, then one of its roots must be this. Either this was 1, this was 1. Either this positive is a root. I'll use long division to reduce this equation to a cubic equation, and again factorize the cubic equation if it's factorizable. If the cubic equation can be factorized, I'll factorize it, reduce it to see which of these would be a root to this equation. So I begin with the positive or -1. So let me try with Let me begin with x equals to 1 and see whether it's a root. So I put x where 1 where there is x. So this would be 3, 1 raised to 4 plus 2, 1 raised to 3 minus 15, 1 raised to 2 plus 12, 1 minus 2. So you can just use a calculator. This will be 3 plus 2, which is 5, minus 15, that gives you negative 10. Negative 10 plus 12, that gives you positive 2. Positive 2 minus 2, that gives you 0. So yes, x equals to 1 is a root to this. So we've already found one of the solutions. X equals to 1 is a 0 to this equation. So what can we do now? Since we've known that x equals to 1 is a 0 to this equation, we now take that x, bringing 1 the other side would be negative 1, and divide into 3x raised to 4 plus 2x cubed minus 15x squared plus 12x minus 2. So we want to divide this into this to get a cubic equation that will again reduce to a quadratic equation. So ask ourselves, how many times does x go into 3x raised to 4? And the answer is that it will go there 3x raised to 3. So 3x raised to 3 times that will be 3x raised to 4, and 3x raised to 3 times this will be negative 3x raised to 3. Just as we do long division with the real numbers, we will subtract. So this will give us 0, and this will give us 5x raised to 3. Then as we normally do long division, we will bring this one down. So it will be negative 15x squared. 15x squared. So again, ask ourselves, how many times does x go here? And x goes here plus 5x squared. 5x squared. So 5x squared times the whole of this gives us 5x cubed minus x squared. Bring 10 minus 10x minus 10x. So minus 10x times this will be minus 10x squared, and minus 10x times this will give us minus 10x. So again, subtract. This will give us 0, and this will give us what was it? It was plus. Oh, just a minute. Minus 10x times x squared will give us minus 10x squared, and minus this minus times this minus will give us positive. Give us positive, not minus. Give us positive. So subtracting this twice, minus 2. Subtract this and give us 0. So we have gotten a cubic equation of this cubic equation. But remember, we already have one solution, that x is equals to 1. So we want to find out what is the solution to this cubic equation. So let me just erase this part. Let me erase this part here. This was 3. This was 3x cubed. Now, so we already see if we can get another solution. Want to find out whether this one can be reduced. So that means if it can be reduced, then one of its factors must be r over s. If we still have the same, this time is positive 2, and this. So we still have the same, that r over s will be plus or minus 1, plus or minus 2, plus or minus 1 over 3, plus or minus 2 over 3. We still have the same, because we still have the same constant 2 and 3. So this, again, we try and find out which of these is a solution. So again, let's try begin with the easy ones. If we find that they do not agree to be solutions, we move to the second one, and then move to the third one, then move to the fourth one. But one of them must be a solution if it can be reduced further. But if, then it means it can be reduced further. So it means that the only way we can solve it maybe will be by now by drawing plus 5 1 raised to 2 minus 10 1 plus 2. What does this give us? So this is 3 plus 5, which is 8, minus 10, which is negative 2, plus 2, which is 0. Good. So again, we've seen that x equals to 1 is another solution. X equals to 1 is another solution. It's a solution to this. A solution to this. So we want to factorize this one. Let me just show you what we have so far. What we have so far is that 3x raised to 4 plus 2x squared minus 15x squared plus 12x minus 2 is the same as x minus 1 multiplied by 3x cubed plus 5x squared minus 10x plus 2. This is what we have so far. That we have factorized this to be this. So just trying to find out whether this one can also be factorized further. And we've seen that x equals to 1 is a solution to this. So it means, what that means, that this one cross and be x minus 1. And let us divide it into 3x raised to 3 plus 5x squared minus 10x plus 2. Plus 3x squared. Subtract this, you have a 0 here, and you have 8x squared. Bring this one down, you have minus 10x. So this will go there, 8x times, so 8x. So 8x times that, you have 8x squared and minus 8x. subtract. This will give you 0, and this will give you minus 2x. Bring this one down. You have plus 2. You have plus 2. So how many times does that one go there? It's minus 2 times. So that will give us minus 2x, and then plus 2. Subtract, and you get 0. So what do we have? So what do we have? What we have now is that the cubic equation, this cubic equation, can be factorized. So let's just write what we have. Let's write what we have currently. What we have currently is, just write it, initial equation x 3x raised to 4 plus 2x cubed minus 15x squared plus 12x minus 2 can now be written, we now know it can be written as x minus 1, and instead of that cubic equation that we had, we have seen that that cubic equation can be written as x minus 1 multiplied by this quadratic equation, which is 3x squared plus 8x minus 2 minus 2. Okay, so we factorize. We've managed to factorize this. Let's see whether we can factorize this. Is there a possibility of getting two values a and b such that their product is negative 6 and their sum is 8? Is there a possibility that we can have two terms where, so I'm looking at how to factorize this. So I'm looking at there are two terms which when multiplied give us negative 6, and when added they give us 8. And those two terms are not there. I cannot see them. I cannot see them. Maybe you can see them, but I cannot see them. So since I cannot see them easily, let me just use quadratic formula. Let me use quadratic formula. Just a minute. So let me use this eraser. You know what we have? Let me just write for you what you have. This equation was equal to 0. That equation was equal to 0. So what it means is that we must equate this to 0. We must equate that to 0 because this was equal to 0. So if that happens, then it means that each of these equals to 0. X minus 1 equals to 0, meaning that x is equals to 0. This one we've seen that we cannot factorize it. Let's find the value of x using quadratic formula. So x using the quadratic formula will be equals to negative b plus or minus the square root of b squared minus 4ac over 2a. Over 2a. This is a quadratic formula where b is 8 minus 8 plus or minus 8 squared negative 2. So it becomes positive 24. Positive 24 over 6. 2a. 2a. A is 3. So 6. So this one can be done. You can use a calculator. You can use your calculator to find this. In fact, inside the bracket we have 88. You have 88. So what is the square root of 88? Let me just use my calculator. I'm using my calculator here, and I'm getting x to be 0.2301. It's a very long thing, but let me do it to 5 1, 2, 3, 4, 5 decimal places, and the other value of x that I'm getting is negative 2.8968. That is a very long value. So we have our solution to this equation. We have our zeros. So our zeros are x equals to that, x equals to that, or x equals to 1, as we saw here, or x equals to 1, because this must have 4 solutions. And these are our 4 solutions. X equals that, x equals that, x equals that, x equals to this. So that is how I solve this equation of degree 4. But you could also use other methods, like you can graph this. You can graph it, and when you graph it, you would also get the values of x where it's cutting the x-axis, where this one cuts the x-axis. So it's supposing you have the y-axis and the x-axis. So just try to graph it and read the positions where the curve is cutting the x-axis, and that again will give you solutions to this equation. Thank you.